I'm happy to welcome a very, very long, an old friend whom I've known for very long, Michael Arbib, and he's emeritus professor of computer science, biomedical engineering, biological sciences, and psychology at USC. He's worked on countless areas, computational areas, computational neurolinguistics, neuroscientific areas on wet neuroscience. I don't know, have you done wet neuroscience, Michael?
No, I've only worked with people who do wet neuroscience.
Well, I'm glad to hear you. For our purposes. And also evolution of language, another thing that we have, interest that we have in common, the origins of language. And Michael was here speaking about the subject about, I don't know, about 15 years or 10 years, 15 years ago, I'm not sure. No, so I'll leave that. The title of his talk is The Evolution of the Construction-Ready Brain. Maintenant, je vais présenter Michael Arbib. C'est la même chose que je viens de dire en anglais. Je le connais depuis toujours. Il est professeur à l'University of Southern California, c'est une université en plusieurs, exactement les disciplines des sciences cognitives, neurosciences, informatique, psychologie, tout ça. Et puis, il s'occupe avec les neurones miroirs dont il va parler, l'évolution du langage dont il va parler, et l'évolution de la constructivité en communication. Je ne ferai pas d'effort de dire ce qu'il va dire, c'est lui qui va l'expliquer. What I said was, I'm now passing it to you, and I said, I will not try to explain construction-ready brain. I'll let you do it. Michael Arbib.
Okay. Thank you. So, as some of you know, I've spent a lot of time trying to model how the brain works, so to speak. And from that moved on to how did the language-ready brain evolve? And in recent years, I've become very concerned with not only language as it is now worked, but also with architecture. And so construction-ready brain is trying to revisit the language-ready brain from an interest in architecture. And I'm advertising at the top a symposium I hosted last year on how humans came to construct their worlds, to explore this idea that humans both build physical objects and change their physical world, but also they create worlds through language and myth and so on. Now I just have to find out what's the right way to advance slides. Okay, well, this is just to celebrate the long acquaintance with our host and say what a pleasure it is to be back with him, even if virtually.
It didn't switch, Michael, it didn't switch. You're still on your head slide.
Oh, well, that's weird because it switched for me, but oh dear. A technical glitch.
Okay. If worst comes to worst, I can do it. There you are. You got it.
I don't know why it worked that way, but okay, I will use a different.
Okay, now they're switching. Now they're switching.
Okay. What can I do? Well, it's been a great slide show, and I hope you enjoyed it. And now we can move on to the questions. I was going to say that when it automatically went to slides. All right. Well, never mind. The slide that you can't see at the moment was a youthful Stefan Haned, and the title of a paper he published of mine back in 1979, a work with David Kaplan, a neurologist who used to be at McGill, I believe, and the title of the paper was Neurolinguistics Must Be Computational. So anyway, the theme of this talk is going to be very much a grand overview with an invitation to dive in and look at detailed papers if you wish. But the notion is that humans, unlike other creatures, have language, and they have a form of physical construction that is qualitatively different from that of other creatures. They can drastically change their physical worlds and construct elaborate symbolic worlds. But on the other hand, if we look at human history and prehistory, much of what we take for granted today wasn't there a few 100,000 years ago. So there are really two issues: what prior evolution led to human brains and bodies very similar to ours, that in some sense were ready for language and ready for construction in the physical sense, but didn't have much of that at the time. So, for example, we know that in recent millennia, we have invented writing and cities, and nothing, we believe, has changed drastically in the genotype in the time between. So we can say our ancestors were writing ready and city ready. So what made us ready for the cultural evolution that led to language? Still trying.
Yes, it changed. Good.
Okay, so just a deep historical dive on the background. Way back in 1972, I published a book called The Metaphorical Brain as an introduction to cybernetics and artificial intelligence. And partly it was based on already a comparative study of brains, comparing frogs, monkeys, and language, and humans, but also was insisting that we should not think of language in a Chomskyan sense as some divorced faculty, but rather think about action-oriented perception as the basis for language. And since Stefan is so worried about time, I won't read the quotes. But the idea is, how is it that creatures that did not have even the readiness for language evolved to give us creatures that could, in fact, in due course, invent language? So just mention a couple of words: embodiment and grounding. Nobody agrees on the definitions, but I will say embodiment is a lot of nonsense in general, I think, talking about bodies without saying what the bodies are. So if you have a different body, you have a different embodiment. And I think that's part of what we have to understand. And the grounding is that each child initially acquires knowledge of the world through physical and emotional interaction. But I'm not convinced that we need maintained grounding. In other words, if I'm doing abstract mathematics, I can, when necessary, return to physical examples. But in general, I'm able to work at a highly abstract level. So I just notice here then this paper that we wrote in 2014 called Language is Handy, but is it embodied? Because of our theory on the relevance of manual dexterity to the early evolution of language, but the idea that language can build towers of abstraction. And so I think that's related to what I see as a related approach by Angelo Cangelosi when he looks at developmental robotics for language grounding. Vittorio Galeazzi, I think, overdoes it and sees embodiment everywhere, whereas not necessarily where it's justified. And Marco Iacoboni reminds us that the systems we'll be talking about are engaged in affective mechanisms and empathy, as well as the more symbolic and practical things that I shall be emphasizing today. Let me just mention again, because I'm interested in comparison of different creatures, von Uexküll's classic study, a stroll through the worlds of animals and men. And he considers that if you take different species of creature, put them in exactly the same environment in some objective sense, what they see and what they do will be quite different. And so he talks about the Umwelt. This is the environment as perceived through the senses and interacted with through the available effectors of the animal. But what is interesting for us is that humans can go beyond that to live in diverse worlds, not only past and imagined versions of the physical world we live in, but diverse other worlds, including realms of abstract knowledge. And I was fascinated to see that Olivier Georges's talk next week will in fact mention von Uexküll's notion of the Umwelt, so you may find some interest in comparing our two approaches. Okay, so neuroethology is the comparative study of animal bodies, brains, and their behavior. And so as the body changes, the brain may change more. And I like to use the word embrainment and not just embodiment. If we think of the body in terms of the effectors, the perceptual apparatus, the way they're disposed on a physical body, what the brain can do inside can crucially change what that body can experience of the world and do in the world. And now just a brief mention of one of my speakers from the October symposium, Susan Healy. She studies the zebra finch, which is sort of the standard system now for studying birdsong, but she studies it in terms of how they build their nests. And what I think is very interesting is that if you put the bird in a different environment with different materials, it will somehow find a way of exploiting those materials to build a nest. And what is interesting is that if the bird is building a nest in one site and it observes other birds building nests elsewhere, having more successful fledgings, then they will relocate their nest. So they're capable of adaptation to the environment. They're capable of learning through their own experience and learning through social experience. And yet, despite all that, the nests they build are very much species specific, despite all these variations. And so I really want to understand, what is it that allows humans to transcend that species specificity, in the sense that what we do now as we build skyscrapers or little cottages in the countryside is so very different from following a genetically provided plan for what we can do in the way of construction. Anyway, at right, we see some of the creatures that neuroethology might study. My own group has looked at frogs, rats, monkeys, and humans, with a glimpse at chimpanzees. So just to advertise then, Susan Carter's talk is called Bird Nests, giving that adaptive variation on innate bough plans, building plans. But the idea is that nonetheless we are seeing in those creatures their variations on a given mode of construction. They're not imagining totally novel forms of construction. And there's a paper that we co-authored with Fragasi and Stout, where we looked at tooling and construction, from nut cracking and stone tool making to bird nests and language. And then, just to again advertise this symposium, how humans came to construct their worlds, I think if you just search on Carter Humans Construct Worlds, you'll find a page that links to the biographies of people, but also to videos of their talks. Okay, but I'm concerned with how we got language-ready brains, we humans, and for that, I need to restrict myself to closest relatives, the monkeys and the apes. And so the slogan will be that LCAM, the last common ancestor with the monkey, is about 25 million years ago on this family tree. The last common ancestor with the great apes is about 5 to 7 million years ago. And we humans share many characteristics. The claim is that they established many of the things that underwrite our ability for language and novel construction, but we are clearly different. But that raises another question, answered by one of my other speakers, that the notion of what means to be a human is now much broader than Homo sapiens, thanks to results by Larry and many other archaeologists. His talk was Combinatorial Technology and the Emergence of the Built Environment. And here we see another family tree, and this is not for the grand scale where humans are one little block on the tree, but rather where we have all these different branches of hominins. And what is of particular interest then is that if we look here, we see modern Homo sapiens. And if we go way back here, 400,000 years ago, we find that Larry's group, digging at Colombo Falls in Africa, found that there were wooden constructions. They found beams notched in such a way that they could be fitted together, maybe to form a platform. And they showed that although there were no trace of the tools involved, they think that not only were stone axes involved, but the stone axes had to be provided with handles to allow notching. So that's 400,000 years ago on our ancestry, but not part of modern Homo sapiens. And if we go to the right, we see that there's a cave in France called Bruniquel Cave, and another group of researchers found that 175,000 years ago, back here, on a totally different branch from that which led to Homo sapiens, there were stalagmites torn down and arranged in circles. So what this says simply is that if we are to understand our evolution, we're going to learn that some of the things must be established way back, and then other things must have evolved independently on separate lines, but all of these make diverse ways of trying to construct what we mean by a human. Okay, I'm not going to get into details of many of the other talks, in fact, but let me just mention the four people who carried the discussion forward in the discussion of archaeology and anthropology. Paul Memmott gave us a very interesting perspective by looking at the relatively simple, well, very simple architecture of Australian Aboriginals as in place before the colonization, and yet the incredibly rich symbolic world that they had constructed on a continent-wide basis. Trevor Watkins took us to the Holocene to look at the Neolithic period, to look at the transition from living in caves to the first buildings in Southwest Asia. Ricardo Brown looked at Göbekli Tepe, which some of you may have heard about as a possible start of the belief in the gods, an idea that she dispelled. And then Michael Smith brought the story forward to maybe 8,000 to 2,000 years ago with how people learned to live in cities. But returning to my own approach that informs everything I'm trying to say today, is we come to the mirror system hypothesis. I'll mention why it's mirror system and why that doesn't matter too much in a moment. But it's the idea that we want to understand the biocultural evolution of the language-ready brain, and I'm going to suggest that involves imitation of manual skills and then pantomime, and then how once our ancestors did have language-ready brains, what was the mechanism for the cultural evolution that led to languages? What do I mean by language? Well, for that, I'm going to say that the idea is that you've got lots and lots of words, and you've got lots of methods called constructions. Part of the perhaps the initial pun that led to my interest in today's topic. But you've got tools called constructions for snapping words together to form combinations that convey new meanings. And so the idea then is that once we have a language-ready brain, simple proto-languages are part of the social evolution that led to them, and then complex proto-languages, as we add more words, add more powerful constructions, and then there's no hard boundary. When a proto-language is complex enough, we can think of it as a simple language, and so we evolved to the languages that were in place in the last 5,000 years or so. Okay, so let's start with this evolutionary story. The idea is that if we're to understand language as it evolved in humans, then it's rather intriguing, isn't it, that unlike those songbirds with their wonderful but relatively meaningless songs, modern non-human primates have manual dexterity, but very, very limited flexibility of vocal control and learning. So my first postulate is that if we try to gather what is shared by current monkeys and postulate for LCAM, our last common ancestor with the monkeys, then they're going to be manual dexterity, action recognition, and a few innate vocal calls. But when we move on to a mere 5, 6, 7 million years ago, to our last common ancestor with the great apes, the suggestion is that we add to being able to see what others are doing and reacting in some way to actually be able to imitate what they're doing. But what's interesting in the apes is that they don't seem to look at the details of the movement. How did I do this? But rather, what is the sub goal you achieved? And then let me figure out how to do that myself. I refer to that as the IKEA effect, and some of you may figure out what I mean by that. But they also have an innate repertoire of manual gestures that can be augmented by novel gestures. So I'm taking, in some sense, as my starting point, maybe manual gesture rather than vocalization is the key towards the evolution of human language. So, all right, here's mirror neurons. And this was a discovery made in modern macaques, but we postulate that this goes back to LCAM and then is a constant in the, well, it is a basis that continues, but is acted upon and expanded in the evolutionary path to human brains. So here's the data very briefly. And you'll notice that one of your speakers, Vittorio Galeazzi, who was one of the group that discovered the mirror neurons back in 1992. And then Marco Iacoboni, who's another of your speakers, later I introduced him to Giacomo Rizzolatti, leader of the group, and they worked together on brain imaging in humans related to the general idea of mirror systems. Anyway, here's the idea. We established that in a certain area of the brain of the monkey, F5 of premotor cortex, every time the monkey performed a precision grip, a particular neuron would fire very vigorously, as demonstrated in this histogram that sums the firing over 10 trials. But then the amazing discovery was that when the experimenter was using a precision grip to place a peanut or other reward on a tray to pass it over to the monkey, the cell fired vigorously as well. So mirror neurons are those that fire not only when the monkey is executing a certain class of actions, but when the monkey observes a related class of actions. And so, as I say, Galeazzi and Iacoboni will have something to say that may relate to their understanding of mirror neurons. But in the story that comes, I should say that, all right, somehow this slide got repeated. What is going on here? All right. So in some sense, the breakthrough for Rizzolatti and myself was the anatomy suggesting that the neurons in F5, that area that had those mirror neurons for grasping in the macaque, were homologous, shared an evolutionary path with Broca's area, which is well known as a speech area in classic aphasiology, for example, going back to the mid-19th century. So this seems to be a paradox. What links hand-related neurons to a speech area? Fortunately, I had spent... Oof, why did it do that? Uh-oh. Okay. Fortunately, I'd spent time with Ursula Bellugi, seen here at the Salk Institute, and she was working on sign language. She and her husband came up with the first grammar of American Sign Language, but also they worked with others to study what happened when people with sign language had damage to Broca's area. And the answer was they had aphasia in the sense that they could master a few words at a time, but couldn't really put them together fluently. And so this, coupled with our own use of the face and the hands, I'm moving my hands down here even though you can't see them, in co-speech gestures, says the paradox is resolved by saying that language is not just speech. And so language evolution is not speech evolution, and therefore we can think about what is it about language that evolves in relation to the eyes and the hands, or the body more generally, or in relation to the voice and the ears, and what is the core that had to evolve to make these couplings possible. So the mirror system hypothesis says, going way back in comparative ethology, we have recognizing the action of others and learning to change one's own actions is the key to social learning in diverse species. We saw that Sue Healy discovered that even in birds deciding where to build their next nest. But we build on this hypothesis, to hypothesize a path to the human language-ready brain that emphasizes manual actions. Now, here's a key observation. By emphasizing dexterity rather than vocalization, I'm suggesting that it is our linkage of brain and body, as evidenced in our primate ancestors, that links being language ready to being construction ready in the practical form. That once we have got to the stage where we have a brain that can put words together, we can also put other ideas together that can be expressed in terms of novel constructions. Okay, so then we forget about mirror neurons as such and just look at the ability for action recognition and imitation. And the crucial innovation after the great apes, I suggest, is that we don't simply look at, oh, you did this, then you did this. We say, oh, that's how you moved your hands to do this. Oh, that's how you moved your hands to do that. And so that becomes complex action recognition, seeing those means to the ends of different subgoals, and imitation, transferring that recognition to things. So this is crucial. And so this expands the ability of proto-humans for new skills to propagate through the community. Now, the next stage is ad hoc pantomime. Now, I keep changing my mind on what adjective or prefix to use on pantomime. But the idea is, imagine you're in a foreign country and you're trying to get something unusual. You don't know the language, and you use your hands in a way that you hope will convey what you want. So this is what I call an ad hoc pantomime. This is as distinct from, there seems to be an international pantomime of raising a hand and scribbling in it when you need the check in a restaurant. So the difference is, we start with ad hoc pantomime where animals, proto-humans, began to recognize that one could act without acting upon a particular object, and this was conveying something about maybe what the object is that is involved and so on. So this is important. It's not just that the individual has to acquire the ability for ad hoc pantomime, getting the idea that making movements in the absence of objects could convey information to someone else, but it requires the ability of others to recognize that a performance is an intended communication rather than an attempted but failed practical action. So the crucial next step from ad hoc pantomime towards language, towards what I call proto-sign here, is conventionalization. And I'll avoid the going back, the videos are missing from 3 million years ago, but here's an example from American Sign Language. If you make a hand shape that sort of looks a bit like an aeroplane with its wings extended and move it through the air, this might be your way of pantomiming as an ad hoc pantomime, a plane flying. But the problem is that what do you talk about a plane on the ground, or what do you want to talk about something else flying? And there we begin to see the break towards not only new words that are conventionalized, but also towards constructions that can put them together again. So here we have the solution adopted by the American Sign Language community is that if you make that hand shape and put it through the air along a trajectory, as shown at right, then this is the sign for fly in the sense of the verb of flying through the air. But if you just move that hand shape back and forth in a narrow range, that is the sign for airplane. As this, and note the difference here. The pantomime is where you don't assume the other person knows any particular way of moving their hands to convey a message, but you hope that by doing it in enough detail or enough times, you will get the message across. Here, a community is agreeing that we are going to take that pantomime and formalize it, conventionalize it in such a way that we can now make distinct and more precise meaning. So we're reducing the ambiguity. But the problem is you have to be a member of the community, learning in the community, to know what the choice was. It could easily have been the other way around. Okay, so in other words, what I'm saying is that my hypothesis is that what you have then is, thanks to this transition from manual skill to imitation of manual skill to pantomime of manual skill to proto-science conventionaling, that is that non-human primates, because non-human primates have flexible manual control but limited vocal control, I'm insisting that what comes first is proto-sign, the ability to use conventionalized signs that may be pantomimes, but may eventually be or new signs coming from other purposes. Then the situation is that somehow humans got flexible and learnable vocal control. And here I have to tell you that this is, as we admit down here, this is very controversial. There are some people who say, well, birds have vocal control, whales have vocal control, parrots have vocal control. So sure, why couldn't humans have developed it? So Steve Mython is somebody who thinks of Neanderthals as humming, and only later did the ability to control the hums to convey meanings emerge. So I just suggest that if you say, well, obviously we're evolving speech and spoken language, rather than saying we're evolving language more generally and manual may come first, then you've still got to prove how it is that humans got the ability to have the vocal control involved. Okay. Now, another thing I want to suggest is that as we move on to the cultural evolution of language, we can imagine different groups doing different things with very simple proto-languages. But I think this is crucial to think of how did we evolve a Chomskyan grammar of grade 2 or something like that, but rather how did humans go from the idea that there are just a few words that they could add to their basic gestural vocabulary, as if there was no change, to finally get into the stage where they've got so many words and so many novel ways of putting them together, they suddenly get the idea of, aha, this is something we can do. We can create new words. We can do this rather than it happening on a multi-generation basis. So, I'll just say, consider this: work, coordinating action, raising children, making a fire, hunting together. Each of these are targets for cooperative behavior. Each of these could have come up with some pantomimes that eventually were conventionalized to put them together. But the idea is that once a tribe of, say, 30 or 40 people has developed 5 or 6 of such micro proto-languages, then the stage is set for building larger proto-languages, and we're on that path towards language. So, in other words, MSH7 says that with the emergence of modern humans, cultural rather than biocultural evolution dominated. And now I just want to briefly note 2 conflicting views. The compositional view of Derek Beckerton, which is probably the one most accepted within the language evolution community, is that, oh, well, proto-language got to the stage where we had a few nouns and a few verbs, but we would just put them together. If I would say things like bring spear, or spear bring, I don't really need syntax there. I'm just getting a message across to you with a noun and a verb. And then strongly influenced by Chomsky, the idea was that language emerged by just adding merge. In other words, put some words together. And then in a more recent book, 2014, he critiqued somewhat merge by moving from a pure syntax putting words together to a more semantic putting words together. But I've written some strong critiques of why I think Chomsky and Berwick in their book, for example, Why Just Us, Language Evolution, are completely wrong, but I won't bore you with the details now. The contrary view from Alison Ray, and myself is the holophrastic view. So if I do a pantomime, I'll come back to an example. If I pantomime opening a door, there's nothing how might I do it? I'm not going to have a separate pantomime for door and a separate pantomime for open. I'm going to perhaps move my hand to indicate turning the handle or the knob, and then I'm going to move my hand in a trajectory. And I might also have a pantomime for closing the door, which starts with the same movement and then but then keeps moving in an opposite direction. So as you get from these hollow phrases where the meanings are combined in one pantomime, or perhaps more later a sequence of pantomimes, then they may be fractionated, broken apart. So what happens here is what is common between those two pantomimes. I mean, this is not an example from ancient times before doors were invented, but it's to give you an idea for which you have modern intuition. Then you might say, well, there are two pantomimes there, and oh, look, here's something common to them. And so I'm going to use that whenever I want to tell you about doors. And now that movement becomes open and that movement becomes close. And so now I have I've moved, as it were, from these holophrasic things to three words, as it were: door, open, and close. But more than that, by putting that fractionation of the pantomime into two pieces with their own special meanings, I've now got a construction. So I can have a general construction, open X, where at the moment I only have door for filling it in, but then if I come up with a sign for mouth, maybe this will be an oral pantomime to signify mouth, then I can say open mouth. So I've got this wonderful thing that not only do I move from these hollow phrases to discovering words and I'm discovering constructions at the same time. And then once that machine gets going, one can see a rapid evolution as people say, oh, I want to talk about opening something else, or I want a sign about opening something else. How do I sign or speak about that particular thing? And so we now get the beginning of constructions, the beginning of syntax. Let me do one more example from modern example, though. I want to emphasize that constructions needn't work with general syntactic categories like noun, verb, adjective, and so on. In fact, as I'm saying, the first constructions and words were long before those categories existed. They're a reflection on the richness of language as it emerges. But consider the slogan the statement in English, the woman in red. Now, that's a very specific construction because actually it means not, it can't be used for a woman sitting in a pool of red paint, for example, or surrounded by red flowers. It means specifically the woman is wearing red clothing. So that the first slot has to be in general a human being, and the second slot has to be in general a color, but then it has this general interpretation, this specific interpretation. Okay, so this slide basically talks about what I've just said. So let me just mention two of your seminars that may be relevant. Angelo Cangelosi, I think, is on the right track. It fits with the paper that I mentioned earlier about language is handy. If we want to understand language in humans, then we have to think about how the child gets language. And the idea is that it starts small. It builds a small embodied vocabulary. But as my paper suggests, once you get going, then you're no longer confined by the embodiment. Piantadosi's paper, I think, I don't know whether it's relevant. I mean, modern language.
Michael, he's a co-author of Daniel Everett.
Yes. Well, I have my reservations about Daniel too. I'm in correspondence with Daniel, and we agree on some things and disagree on others. But no, the reason I think this is a mistake is it conflates two different things. One is modern language models. If you're talking about large language models, you're talking about how do I take a corpus of complex language and train a system to statistically analyze it to be able to use some of the information in there. Whereas Chomsky's approach to language includes this idea of the poverty of the stimulus and the idea of how the child acquires language. and the idea of a universal grammar. So arguments against Chomsky's approach to language and arguments of how to build better large language models, I think are disjoint topics. But anyway, that's not the point of this talk. Anyway, so what I've said is just simply that fractionation yielding new symbols also yields emerging constructions, providing new ways of putting together these new meanings. And as a group masters that encourages the creation of new words to flesh out the constructions, which encourages the development of new constructions over things. And what I'm insisting in the approach I've offered is that it's complex imitation, recognizing variants of an action as ways of combining sub-actions in flexible ways that achieve sub-goals under varying circumstances, when applied to communication, makes this possible, because we have a theory not only of what is language as a way of putting words together to convey meanings, but a theory of how is it that people come to recognize what others are saying, and how do people come to acquire that skill. Okay, so to take volumes and volumes of discussion and compress them into one slide, what I've tried to suggest is that the theory I've shown is how language and physical construction are part of the same evolutionary process, and they become central to being part of a human community, so that Homo sapiens, that's the human who knows, is both Homo loquens, the human who speaks, or signs, as I've suggested, and Homo faber, the human who constructs or makes. What I want to suggest, and this is other talks, not today's talk, but worth noting, is that once we have language, we can ask questions and tell stories. Homo narrans, the human who tells stories. Homo querens, the human who asks questions, as kids do as they build their knowledge of the environment in which they're growing up. But the notion is more generally, and this takes me back to the book on natural theology that I wrote with Mary Hesse back in the 80s that I flashed at you on a slide. As humans asked existential questions, they created stories that shaped the symbolic worlds of myth, religion, ideology, and more. And that's a theme that takes us well beyond today's talk. Okay. I have to learn to click on the right place. So in the final, I've got 18 minutes. Very good. In the final section, I want to briefly show how the evolutionary path we've charted for the language-ready brain has indeed created a brain that is physical construction ready. And I leave it to you to think about this, that it's culture ready more generally. But anyway, let's look at this. Just a quick look about how we've already, in some sense, got a drawing-ready brain. At right, we see Chauvet. At left, we see a coffee cup. And my point is that once you've got pantomime, which is moving your, so you might move. Oh, okay. I do wish this wouldn't happen. Okay. That once you've got the ability to, for example, you might want to convey the coffee cup through pantomime, not by either by pantomiming, putting your finger through the handle and then lifting the cup to your lips, but you might also do it by pantomiming the shape of the volume of the cup and the saucer. And so once you've got that ability to pantomime events, actions, and objects on the path to proto-science, you've got contours as a bridge from objects and actions to drawing. But of course, drawing only works if you've got an appropriate technology. And so we need something like pieces of charcoal and cave walls to make enduring marks, and then later chisels to create bas-reliefs and so on. But also note also complementary roles of patches of color. So the archaeological record shows that humans were using ochre at least 300,000 years ago. We're back again, pre-Homo sapiens. And so the suggestion is you might have a confluence. So this is interesting. I don't want the evolution of my thinking over the last 1,000 years has been when I understand that something can be a powerful mechanism, I discover later that yes, it does a lot, but gosh, look, here's another mechanism lying around there. And so the essence is, how do they work together? So in this case, the notion is that humans may well have adopted ochre for things like body painting, perhaps imitating the plumage of birds, another way in which birds are relevant to our story. But of course, that left no trace. You could find the sticks of ochre. You could find maybe the palette of a couple of different colors of ochre, but you couldn't find traces of how it was used that long ago. But this meant that you had patches of color. So if you have people who suddenly have ways of making marks on a wall that are enduring, they can start smearing ochre on the wall as well and come up with a more vivid representation. But I want to go back again to this more general perspective of saying that I've taken the idea that our primate ancestors had dexterity, manual dexterity, and to suggest how, but lacked vocal dexterity. So what's a path that could exploit that manual dexterity that could bring us towards humans as we know them today with the use of language? But of course, when we step back to our ethology framework, animals must find food, they must escape predators, they must produce offspring. All this requires knowing about places in the world, and for many creatures that involves the species-specific construction of new places. So we've already talked about bird nests, and here's an amazing picture from my front courtyard where an orb spider has somehow managed to attach two guidelines to the beak of this iron heron and then make this amazing web, which will be its place to capture and then eat flies for 2 days, after which it will itself eat the web to preserve the valuable protein and then start the process all over again. But anyway, that notion is that places are very important things to think about. And so, again, I emphasize the point I made in discussing about Sue Healy, that for humans, though, construction of new places escapes the bounds of adaptive variation or innate bower plans. So let me just go back to that spider's web again. Notice that there is a place in terms of where in the courtyard is the web, but then once the web is created, it itself constructs a place of places, if you will, a structure of places. And I have a whole theory about that, but not today. Okay, so let's switch then finally to architecture. I'm going to quote in a little while, later on, the work of Peter Zumthor, who's an architect in Switzerland, but is currently, and rather controversially, working on the building of a new space for the Los Angeles County Museum of Art. But anyway, here's one of his masterpieces, the Thermae Vals. And what's interesting is the way there is an environment. He then places the building in the environment. He then structures the new places within the building so that in part the appreciation in the environment can be part of it. But the main thing is the baths. And so we have different baths, and then you create a multi-sensory experience of stepping into the water. There are some flowers in some of the baths to add a sensory sense of smell and so on. So place has this multi-sensory thing. A lot of the time we tend too much to emphasize the visual. But what is a human place? And so you may recall that Jacoboni talks about the affect and the emotion, and there's a lot of very interesting stuff now on monkey studies looking at a different part of the mirror system, different from the grasp-related area, that does seem to tie in with the emotional system of the brain, and that's another part of expanding the story. But places serve practical and aesthetic functions and create emotional atmosphere. Places can serve as the basis for new narratives, and that, it turns out, offers new challenges for modeling in and beyond the hippocampus. So here's an area that I've worked on for decades, but only now, in the last few years, have I begun to integrate it with this story about language evolution, inspired in part by worrying now about architecture as well as about language. So here are the two classic studies. John O'Keefe, who later got the Nobel Prize for this work, along with two other colleagues who worked on grid cells, studied the rat hippocampus as the rat was moving around the atmosphere. And what this slide shows is here is the tracery of the rat's movements as it explored this little environment it was given. And here is where a particular cell fired. So this area was designated as the place field, the places or place area in which the rat cell fired in its hippocampus, and the cell itself became called a place cell. Notice that a single place cell doesn't tell you very much, but since there are many of them, if you think of the intersection of different regions, then you can get a very precise pinpoint. So there's that area that it seems that the hippocampus is highly relevant to navigation. And of course, human studies have backed up that point. But they've also backed up the point that the hippocampus doesn't work alone. Now, the classic study in human hippocampus is this man HM, Henry Gustav Mollison, as we learned after he died, had grand mal epilepsy, and his surgeon, rather irresponsibly, and this was, by the way, there in Montreal, cut out the not just the hippocampus, but also this huge area of the surrounding lobes. But we take lessons from this about the role of the hippocampus. And a lot of studies were done going beyond, this is the surgery, done by Brenda Milner, who is the grande dame of neuroscience in Montreal. So what happened, what was intriguing, was that he lost episodic memory. He could function quite well with working memory. So but he couldn't remember earlier episodes. Perhaps some of you have seen the movie Memento, in which there was a person who had this, and the movie, I really recommend it, Memento, because it gets its impact because the episodes within it go backwards in time. So you, in some sense, are equally ignorant as he is. And so as you go back, it unfolds of what, of course, he has forgotten and how very different his actions would have been if he had intact memory. But anyway, the intriguing finding about HM was that although he couldn't remember episodes, you could leave the room and come back and apologize for the delay, and he wouldn't know that you'd been there. You could show him a game and play it with him, and as long as the working memory was engaged, not just short term, but medium term, he could play the game and get the rules. Now, you came back the next day, you brought the same game along, he didn't remember you, he didn't remember ever playing the game, but he played it better. And day after day, he'll play better and better. So he had that procedural memory, the ability to acquire new skills, even though he couldn't remember the episodes that occurred while he was acquiring those skills. So this brings a sort of challenges. A lot of people look at hippocampus and episodic memory. A lot of people look at spatial navigation, episodic memory and hippocampus, spatial navigation and hippocampus. And what I explore in the last chapter of my new book is how these might come together. But before we leave the hippocampus, I just want to show you a third hippocampus, thanks to Image Creator on Microsoft, where the prompt was just simply Hippospace Campus. So the other real data that gets us going is exemplified by this work of Shakhtar Adis Hassabis, who just got the Nobel Prize for his work on learning protein structure. but who at that stage was working on the neuroscience of the hippocampus, Martin Springer Schwinner, The Future of Memory, Remembering, Imagining in the Brain. So what they did was that they had people be brain image while they were telling stories about a past event, and have their brain image while they were telling made up stories about some possible future event. And what happened was that actually a lot of brain lit up in both cases, but one of the areas that lit up in both cases was the hippocampus. But I emphasize there are differences in brain activity between remembering the past and imagining the future. And the idea then is that the underlying neural networks can couple flexibly with other networks. So what I'm saying here is that in some sense we followed for a long time a story that looked at the control of the hands, the recognition of hand movements, and the way that systems for that, including mirror neurons supporting some forms of action recognition, could between them provide the basis for a system that could bring us to proto-language and then on to simple languages. But now we're saying, yeah, but what do you talk about? And then, of course, you get into things like, well, places in the world. Where do you build that? Where do you find that? Where do you do that? Okay, so back to Peter Zumthor, whose thermal baths at Valls in Switzerland we looked at. He wrote an essay just called A Way of Looking at Things. And I just want to quote these few pieces because they've inspired a lot of work I've done recently. So he says, construction is the art of making a meaningful whole out of many parts. Now he's talking as an architect here, but also as someone who has built furniture. So I feel respect for the art of joining, the ability of craftsmen and engineers, the knowledge of how to make things. But he also brings in memory, image, and imagination. And now, of course, the bells are ringing for thinking about, well, what's the hippocampus doing here? When I think about architecture, images come into my mind. When I design, I frequently find myself sinking into old, half-forgotten memories. Yet at the same time, I know that all is new and that there is no direct reference to a formal work of architecture. Well, my friends who are architects tell me that, well, it's not true that all is new, but the whole point is that much is new, but it's informed by both one's memories and one's study of other buildings. And that the fascinating thing is that these, in the end, come together in a new way that frames then the filling in of the details for the architectural plans. So here we are, almost at the end. The book that I mentioned in the last few slides is called When Brains Meet Buildings, a conversation between neuroscience and architecture. What I've tried to do is say, what's happening in your brain as you explore a building, as you recognize places in the building, as you look for the affordances for different types of action in the building. What happens in the architect's brain as they try to create a building with this. And even what happens in this world of artificial intelligence, what happens as you begin to build some sort of brains for buildings. By the way, I came up with the title for the book, forgetting that I had this photograph from a visit to Berlin. And one day I suddenly realized just this notion of construction and putting things together, that this was the right picture. This was an installation at the Collegium Hungaricum just around the corner from Unter den Linden in Berlin, where the artistic installation was this guy apparently peering in to the second floor window. In other words, meeting a building. Okay, so just to then say that memory meets imagination of the future experience of others. So I'm saying when if we talk about what Zumthor said, this is the recall of their own experience of prior buildings and drawing on their broader expertise about what it needs to make a building work. But it must also involve the imagination of what behaviors and experiences the buildings will afford future users, and then design the places and the transitions between them that support those behaviors and experiences. So this is something I've tried to write an essay on along chapters 6, 9, and 10 of this book. But this is at a relatively high level and filling in the details remains a real thing. So let me just mention the last three Carter talks, which do look at the theme of modern day architecture. Barnabas Calder worries about energy, looking at what happened as we go from the past, like building the pyramids in Egypt, which I just visited, where immense human labor was mustered to achieve anything, to the situation today where, thanks to exploiting fossil fuels, we can build lots and lots and lots of stuff, but with currently disastrous side effects. Christine Stiffany, I brought in because we often talk about architecture in terms of commissions for rich people building beautiful houses or great public buildings. And this basically is what happens as as the slums are developed informally. And finally, Michael Fox, I gave him this hideously long title, Toward a Smart Architecture of Habitats in the Age of Human AI Symbiosis in an Eco-Aware World. But Michael has a new book just coming out, which I think is very relevant to this discussion of the interaction between construction and language. And he's tracing the notations that architects have used, more in the way of drawings than in terms of words, but combining them in the early stages. And then we get to the stage where, as we get to CAD, computer-assisted design, more and more aspects of what goes into a building are expressed symbolically. And so you can put together a very detailed plan of a building and even use computer graphics to allow people to walk through that building. And now artificial intelligence is allowing the automation of parts of the design consideration. So in conclusion, this talk offered hypotheses that address the question of how biological evolution yielded humans with the construction-ready brains and bodies that made us capable of the cultural evolution that created the diversity of the mental and physical constructs that we know today. The framework for all this is EvoDevoSocio, emphasizing not only biological evolution and the development of creatures according to their evolved genome, but also their social interactions. Biological evolution yields biological mechanisms for both development and adult function of members of a species, but that social interaction is an important part of that environment, and that in humans, cultural evolution has played the crucial role in changing the social, physical, and increasingly symbolic and technical environments in which most humans now develop. The bridge between the constructions of language and of physical objects is provided by the rooting of pantomime and manual action as the long ago branch point that separated us from the evolution of the other great apes. And with that, I conclude. Thank you very much.
Thank you very much.
I did go 2 minutes over. I apologize.
We're open for questions, and usually there's hesitation at this point, and I'm supposed to fill the gap in, but I invite the people who are in Zoom land to just raise your hand when you're ready to ask a question. And here in the audience, I've taken away the camera from the audience, but just raise your hand. Levez la main si vous avez une question. I have a question for you. You've talked about pantomime, and you've talked about construction, as in spatial artifacts and anything that you can do with your hands. I want to bring in another ION word. What about propositions? You said queries. You said I forget what the three homos were, but queries are questions. Propositions are answers. What role does construction have in propositional language, and what's the origin of propositions? You gave the origin from pantomime, how you could get arbitrary and conventional words, but propositions are combinations of words, not just syntax, but words combined to say something that has a subject, a predicate, and a truth value. The cat is on the mat is not just syntax with 2 or 3 different content words. What, in your view, is the connection between mirror neurons, thought, embodiment?
Don't forget mirror neurons, but I think my whole point was that by starting with pantomimes, then you had a mechanism whereby the emergence of words and ways of putting those words together to express situations occurred. So I think that's in germ what you want. Now, I'm not quite sure where opposition came in, but clearly in any human interaction, if two people want to do something, there can be an opposition. I want this. No, I want this. How is that resolved? And then as that emerges, I thought a lot about religions that come up with completely different answers to the question as what is the meaning of life, or what happens after we die. So, but
I didn't say opposition, I said proposition.
oh, proposition. Well, I'm up in but I think language is essentially is not only propositional, right? I mean, if I ask you a question, like pass the salt, I say yes, and I'm not responding with a proposition. I'm coordinating movement, or I may offer a proposition, but it's more of a request, right? Would you do this? Or maybe a command, do that. And so I see propositions as, if you want to have truth value associated, I think that's a rather sophisticated emergent. The idea is how best to coordinate our actions is the framework I'm using in the story I've offered.
It's sophisticated, you're quite right, but we're here in 2025 facing ChatGPT and LLMs that are basically all over the world profiting from propositions, not from just word associations, not from just, what was the two words that you said? You said bring something or other, and then something or other bring. You said it doesn't matter.
Okay. I mean, you're asking me for a different talk. I mean, I have a paper I'm writing now on how we can better distinguish LLMs and diffusion machines from the way brains do it, and ask, how each might profit from understanding that. As we tried to, I mean, one answer I gave you was that as the child grows today, they start with these very simple interactions, want milk, love daddy, and so on. And then as they interact more, they have a wider range of actions. They can talk about them. And very soon the child is asking questions. They ask the word why, right? And mummy has to come up with some form of words at the level the child can understand. And so from that way, you build up a greater range of embodied knowledge. And then you can start talking about these things as propositions, as providing a Fregean or Russellian framework for what's being done. But that's not what's happening to the child at first. With LLMs, you're starting from the other way around. You have a huge body of sentences, and you're trying to predict the next word. And the problem there is that, in general, the LLM has sucked up so much data that there's no person there who has their own beliefs and prejudices and understandings. So if you have if you've sucked up everything on the internet, which is what Trump says, and everything on the internet says what Trudeau says, and everything that sucks up what Putin says, and everything that sucks up what you and I say, then you lose that ability to say, well, from my point of view, this happens. So I'm just saying that I think propositions are important, but I don't think they're central to the story I told today. I think they're important to stories I'm telling tomorrow.
Okay, we'll listen to those tomorrow. We finally, Christian Lebière I've broken the ice, and Christian Lebière is ready to relief.
So also a question, I think, about semantics in the same direction as same general direction as Stephen. So in the case of pantomime and architecture, for that matter, so that's very much grounded in the physical world and spatial and temporal. But obviously, language can cover more abstract concepts. Do you imagine those more abstract concepts to be directly grounded in the embodiment in the physical, spatial, temporal world, or is there a process of abstraction? And if so, sort of like, do you have some thoughts about what that process is like?
Well, as I would say, the least successful talk I ever gave was one in Berlin, where I was trying to make the point that the child starts with embodied use of a simple aspects of language and then develops. And then I was making the point of my own earlier work as a mathematician, to say that we can reach a stage where we can find a path back to embodiment, but we can live on a level, a tower of abstraction, where what we're doing is not embodied. So I used an example from category theory. The problem was the moment I mentioned the word mathematics, the whole audience turned off because, oh no, mathematics is frightening, we don't understand it. And so the point was lost. But for example, Hilbert space is an infinite dimensional abstraction of Euclidean space. And it's been essential, for example, in von Neumann's version of the theory of quantum mechanics. And occasionally I can understand it by going back to my intuition about 3 or 4 dimensional space. But in general, when I'm working on proving theorems about Hilbert space or theorems in category theory, I'm not embodied at all. I'm working on this abstract level. And so, well, is that enough of an answer? You don't look happy.
Yeah, no. Well, no, of course. So first of all, I can imagine why people were a little scared about your discussion of Hilbert spaces. Apparently, Feynman was quite famous for being able to ground very abstract concepts of physics in terms of very concrete, fuzzy-colored balls, as they said. So maybe that's a common pattern. The ability to deal with abstract concept by somehow grounding them. So if I may have a follow-up, do you have some idea of, I don't know, the quantification of abstractness? And again, sort of like, are there layers of remove from that physical embodiment? I'm just trying to get a sense of understanding of that space.
I'm sorry. Etienne sent me a message while you were talking, and as a result, I lost what you were saying. Shame on you.
Oh, that's okay. That's okay.
Okay, what I have here locally is the English translation of many of the questions that were asked by the students. Do any of you, I have all of your questions here. Would any of you please agree to ask the question from Arbib in English?
Or you can just give me the question. You can just say the question in French and Etienne can just show the translation.
Or just raise your hands and tell me that you want me to show your question.
They were very good questions, by the way.
Là, je suis sérieux. On est en cours maintenant. Il faut que vous participiez. Vous avez posé des questions. Soit posez-les oralement ou dites-moi de les poser pour vous.
Moi, je serais curieuse. Elle est là de toute façon.
Ok. Je te sais. Elle est où?
Parent.
Non, mais où est-ce que je l'ai mis?
Elle était déjà affichée, je ne sais pas.
Tout.
Ah, vous l'avez passé. Juste là, en haut.
Okay. Can we trace links between music and singing and the evolution of language? In this sense, if we conceive that the brain is brain ready for language, does this also apply to music and singing, which also originate from a need or desire to communicate? I think that's quite a good question. And we have here in Montreal, I think she's still here. Denise, are you here? The head of the CRLMB, the Center for Research in Language, Mind, Music, and Brain.
So back in 2011, I had a conference in Berlin with representation from Montreal on language, music, and the brain, a mysterious relationship. And I think what I was trying to do, well, I had many people who were experts on different aspects of this. And so I think if one's seriously interested in that question, look up the book, Language, Music, and the Brain. But what I was trying to show was the embodiment could be very important. In other words, don't think of music as abstract sound patterns. Think of it in terms of the dance. And dance has powerful ritual properties as well as powerful emotional properties as well as powerful social properties. And so different people explore different aspects of that. Perhaps the most interesting thing in relation to your question is Jerome Lewis has studied a group of pygmies in Africa who engage in ritual dances that are in some sense propitiating the spirits of the animals they are going to hunt. And there the music, the dance, and the action are intertwined. So that's one interesting thing. Another thing is something called MIT for musical integration therapy or something, where it turns out that if people have aphasia and are having trouble with words, it can help them if you teach them to sing their sentences rather than try to speak them. So, the challenge of the book is the beginning of, well, the continuation of that issue of how does that pattern of social interaction involve the embodiment of actions like dancing, of communal activity, and so on.
Very good. Now we have a question from Jean-Pierre Rio.
Yes, thank you, Michael. I'm very glad to meet you again after all this time while I was visiting at USC. So glad to see you. You're still very active. I was and very prolific. So my very interesting talk, and I'm interested in the bridge. So in a way, a bit like Etienne, the bridge between LLMs and this kind of brain functioning for language and language construction. So I completely agree with you, but I'm not specialist about language evolution like you, that it's a very completely different way of learning than for LLMs, for instance. So I'm aware, in addition to your work of, for instance, the work on the language evolution by Lux Stills, I guess that you're aware of this kind of language games, for exactly to different agents to construct together through social interactions, language and syntax and vocabulary, etc. But I just want to point out, comment that the children and the adults, they also learn and they improve their language and of course their knowledge from reading also, not just social interaction and pantomime, that is reading books, etc. So my point is for the future of LLMs, which are more based on exactly learning from existing artifacts, text, as you pointed out, how this could incorporate this kind of social interaction through robots, for instance, pointing up together on the shared objects and starting to talk about that. So of course it's still an open issue, but maybe if you have some comments about that, the future of LLMs, how it could incorporate the LLM technology, this kind of social interaction in the framework. Do they need to really add some modules, or could incorporate in this existing framework? So I hope I was clear.
Yes. Now, for the next 2 hours, I'll try to offer my answer to that question. No, the first point was that the cultural evolution, as you say, has changed things from people in small tribes with a very limited vocabulary, with a relatively simple lifestyle, to where writing was invented and used to basically propagate myths and to do accounting. those were the original things, to the stage where now there are millions of books available. And then we bring in the 20th century, we bring in recordings. And then later in the 20th century, we bring in videos. And so the language. Now, what's interesting about videos is that it is sort of halfway return to embodiment, right? Because you are now having the language associated with views of people interacting with each other in different types of physical world, et cetera, or engaged in complex narratives in which their emotions are shown on their face as well. So perhaps the short answer for the moment is that I think if you think of an LLM in the classic sense of only here's a corpus, can you predict what comes next? Where everything is already coded as sort of vectors for the individual words and so on, you're not going to get there. Already, though, what is beginning to happen is that you'll see systems in which, for example, you integrate LLMs with picture recognition or with video recognition. And now you're going to be able to get the system at least halfway towards that, because it may not have the gut feeling of the emotion, but at least it has a repertoire of when people express this emotional face, then this suggests they're going to be predisposed to act in that way. So I think you can approximate it. And the other thing is that people who lack arms and legs and so on can still learn to speak, et cetera, et cetera, et cetera.
Take you at your word that this will be the short answer. We've got 9 minutes and 2 questions here in the classroom, and Steve Hansen remotely. The classroom questions were asked first, so go ahead.
Yep.
Loud.
Thank you very much for that presentation. My question was concerning the pantomimes. I think if I understood well, there was pantomimes that were ad hoc in the sense that they are kind of improvised on the moment, and some of them are shared at some point by a group of people. And my question is, can we consider these pantomimes that are shared as some kinds of words in a sense? And if it is the case, then how are those groups of pantomimes different from a proto-language?
Good question. Not long answer. Go ahead. You've got more questions.
Okay. That was an explicit slide was saying where I had the airplane versus flying, where I said that the distinction came when a group went from, I will try a pantomime and hope you understand it, to saying, okay, we've used this pantomime again, there's ambiguity, let's twist it this way, and then you understand it, let's twist it that way, and then you understand it as something different. And then you are finally at proto-words, the constituents of a proto-language.
Okay, very good. We're going to have a talk on disambiguation in general and in spoken language later on in this series. The next question is there. Bref.
Hi. Thanks for the talk. I was just wondering still about pantomime, but more in the current day sense. If we're basing on the idea that pantomime and complex action were created for creating proto-language and then language, for now, when somebody, let's say, learns a sign language that can already speak, is basing itself, the pantomime, not based on the simple action, but is basing on the language to create a pantomime for itself, like the reverse. It is still do the same type of neural activation that we saw in prior works with macaque, or is that a new network that is created in the brain since it's working from a new base of reference?
Did you catch that question, or do you need?
Yeah, close enough. Okay, so pantomime is different from sign language. Sign language is a conventionalized system. Sort of ad hoc pantomime is not. And there are both people who have brain lesions where they can no longer speak sign language but can still pantomime. And there are studies which suggest that even if you look at somebody signing a word that you as a non-signer would think is a pantomime, but they know it's the word of a language, you get different brain activity as shown by fMRI. So, and one last phrase. So we talk therefore about cosine gestures. We're getting into trigonometry here, cosine and co-speech. But anyway, cosine gestures. that are distinguishable in the brain and in the human interaction from using the conventionalized signs of the language.
Okay,
Thank you.
we're gonna have a question from Steve Hansen. Go ahead. And Herb, don't leave. You can say a couple of words before the end about what you're gonna be doing soon here. Steve Hansen, go ahead.
Yeah, hi. How you doing?
Good to see you again.
Been a long time.
I didn't recognize you with the beard, but hello.
Yeah, well, when we interacted, I was much younger. Also, you were at a wonderful workshop here at Rutgers where you asked Jerry Fodor a perfect question. And you remember this? And you said, "Well, what are phones innate, Jerry?" You remember his answer?
I remember more that I was so
the small black ones.
Yeah.
From the 1930s. That was his sort of Aristotelian silly.
You don't have all that time.
I know. So my question is short. So there's a lot of work going on in alignment with LLMs and humans, and there's some really good cognitive psychology, cognitive science, and computer science. One person in particular, Ellie Pavlik at Brown, has been finding all kinds of interesting alignment in prefrontal cortex of human and the attention heads, the 4,000 to 16,000 attention heads that are in an LLM typically. And she's found things like working memory and so on and so forth. Now, as you pointed out quite rightly, they don't have arms and legs and they don't have bodies. But do you think there'll be some kind of proto-mirror system that might be found in an LLM?
No.
Why not? Simply
That's
because
that's another question. Right. No, I mean, the recognizing it's built in. You give them the vocabulary. You give them this vectorial embedding of words. So, and it's programmed that it takes those words in and then it does things and it spits the words out. There's nothing.
No. That's absolutely false. It does not. There's no programming. In fact, there's nothing that we understand about the way they produce language.
I don't know what, well, you're catching me on, perhaps I didn't speak precisely enough, but
okay.
I mean, I know what's inside. So let me give you one critique about what's inside.
Sure.
You have a array of layer after layer after layer after layer, right? And through training, some of those attention units may become specialized for different things, maybe. But what I think is intriguing is that when I'm talking to you, I have in my head some sort of plan of what it is I want to get across, even if I don't know what the next word will be. And then I generate the next word and the next word, but it's within some idea of what I want to express. There's nothing in the design of the basic LLM that holds that. You have to recompute it every time.
No.
But we can't argue that now. Let's continue this. I'd like to continue this offline. Okay.
Sorry. We can take this offline, but I just want to, it's very much the fact that the learning in the neural network provided some kind of structure that we have not decoded and we don't understand. And I'll stop.
Sorry, you totally misunderstand me. I'm not talking about the long-term memory of that encoding. I'm talking about I create a working memory that guides my interaction.
Hang on. I have to do.
I think I have to go.
We'll invite you to give a talk and then you can say your version. Herb, tell us what you're going to be doing.
Michael's right. No, I'm going to try to demythalize what's going on inside LLMs and try to say, how do we analyze what's there? It's basically a recapitulation of the behaviorism argument from the 1980s, trying to build a model that is strictly at one level of words mapping onto words. And I'll try to make some suggestions about where we should go if we actually want to build general intelligence.
Good, that's welcome. And thank you very much, Michael and everybody. Very interesting, very provocative, and very reflection generating talk. See you next week.
Thank you all.